Hello, shall we start?
Yes, sir. Let us start, sir.
Okay.
Plus S, please, S.
Good evening to all of you once again. Um, so, yesterday we were discussing a few ideas, concepts about plotting graphs in SageMath. And I think we have seen a good number of commands for plotting several things in SageMath, like how to plot a basic function. After that, how to plot some commonly known structures like circles, ellipse, and then arrow marks, lines, polygon, etc. And after that, we have done one problem also in calculus, like drawing the tangent line at one particular point given that function and without knowing anything else, right, other than the derivative itself. We use the formula for we use the concept that the slope of the tangent line at that particular point is going to be equal to the derivative. Therefore, we needed to know the derivative function. Because we haven't learned how to construct, how to find out the derivative directly from the function, we manually fed the derivative function into that. Sine, we know that the derivative of cos. Therefore, we explicitly gave that derivative there. But instead of that, we would have used the Sage command itself for finding the derivative, and we would have automated the entire process. Okay, that we will do later. There are a few more things left in the two-dimensional plotting, like implicit plotting, parametric plotting, etc., and a few more controlling options in this 2D plotting. So we will not be going much into 3D plotting, but there will be in between a few things coming up in the 3D plotting as well. So we are not completely going to that 3D plotting part. So some basics of 3D plotting may come in between, because we cannot completely avoid this 3D plotting as well. So okay. So let me start sharing my screen first of all. Yeah, I have already opened one worksheet. What is the name I used to give? The date workshop. Let me just give a name. Okay, before that, let me just turn on live streaming as well. So today it is 11th. So let me just give the name as 11. SageMath. Okay. So remember that we have yesterday seen a few things regarding related to this plotting. Now we can of course see a few more extra parameters related to this plotting itself. And the very first thing I would like to probably tell is that we have seen yesterday that we can give a few colors, right? We can specify a few colors using either the RGB color name or using the color constant. But what are the color constants that that are available for us? Maybe we can directly go and check. Okay, let us just introduce one plot first. Plot the good sine function, very familiar function, where x is in the range minus pi to pi, or even minus 2 pi to 2 pi, so that it will look like a little bit a larger graph. So this is a sine graph. Now I am going to add a few more options. Even before that, what I wanted to say is, what are the options associated with the plot? So that if we want, we can make it more attractive. If we want, we can make it more friendly like that. What are the options? Plot, question mark, and shift enter, and wait for the output to come. Yeah, here comes whatever help is available inside the SageMath related to this plot. I'd say several things, but let us focus to the most important things. So there is something called plot points. Okay, so what is special about plot point? So the special thing about plot point is okay. Let us try to just use that plot points command here. Plot points equal to, suppose we give only 50 points and see how the graph looks like. There is not much difference is there. Okay, let us give 10 points and see. So you might be observing now that instead of the graph being a smooth one, it has become something like a straight line is connected. Okay, so let us reduce it to 5. Okay, that becomes much more obvious. Let us reduce it into 3. 1, straight line, 2, straight line, 3. So what is happening here? Let us once again see what exactly the plot points are. So plot points actually tells that within a short period of the curve, how many points are to be used and how many points are to be connected. The default number of plot points is actually 5. Whenever it divides, okay, I'll just try to explain that. Plot points. It's not actually accepting whatever number we are giving. Okay, let us try to plot. Let us try to remove this number and let us try to use a smaller area. Why the plot points is 3 is not taken care of? Minus 5. Sorry. So 10, 100. Oh, that's a little bit confusing. The documentation is actually a little bit confusing because it is not actually taking exactly 5 points. Most probably it means that within a unit distance it is taking 5 points to construct the proof. But what is that unit distance is not very clear. Okay, let us try to reduce that once again. It is not it is in the entire range minus pi pi, it is not actually taking 100 points or 5 points. Okay, in the entire range it's not 5 points. So what is it happening? So let us take 0, 1 and see what exactly is. 0, 1 is a straight line, so we cannot make out much. So where we should take minus pi by 4 to pi by 4. That's again a straight line. Oh sorry, minus pi by 2. You will take that curvy region there. Pi by 2 plus minus 0.5 to pi by 2 plus 0.5. Let us see what happens here. Even here it doesn't actually mean that okay, how many points are being taken here. If you look at this curve 1, 2, 3, 4, 5, 6. So what I understand from this, I myself not very clear about this exactly. What I understand from this curve is that whenever we are specifying the plot points, it uses 5 points and it uses 5 points, but within what range? Is it within 1 to 2? It's not within 1 to 2. You can see that there are several points. If you zoom this graph, you can see that several points are being used here. So the concept of plot point, if you use only 2, it's a multiplication factor here. It is not exactly 2. You use 1, 2, 3. So the number of points are getting down. If you use just 0, that's wrong. As you can, okay, it's so division by zeros. Then essentially it means that that range is divided into 5 parts. So if we are using 5, so this essentially means that the range pi by 2 minus 0.5 to pi by 2 plus 0.5 is divided into 5 parts, and these 5 parts are connected. So 5 straight lines are basically used, is what I understand, or 5 straight lines or 5 intervals, something like that is happening here. Okay, that's what I can understand from this message, that division by 0. So this range is probably divided using this number 5, and accordingly the points are the plotting points are constructed, and the points are now xy points are constructed and xy points are connected. That's what I understand from this. Okay, let us for the time being, let us probably, we can just take it to be like that. Maybe after this, let me see, plot points we have seen. That is the first option. What is the next thing? Okay, the next thing is the colors available. Okay, we were actually seeing these options here, right? So plot points is one. Adaptive recursion, I don't really think that we will be using it much. The most important thing that will be that we will be using in our course, we will see scale of the axis, linear, log. Okay, let us ignore that. X minimum, X maximum, we were actually using that. Y minimum, Y maximum. Okay, we will try to see this Y minimum, Y maximum as well. So what is this Y minimum, Y maximum? Let us try to take this. See that if you are using this from pi by 2 or minus pi by 2 or even minus pi to pi, let us not take this plot points here. The graph is appearing like this. Okay, now suppose that we give some, so what is the range of this y? Naturally, in the case of the sine function, the range is -1 to 1. Suppose we restrict the y range also, but does it know the y range? Y, but where is that y? There is no y here anyway. Maybe, okay, let us say that y between minus 0.5 to 0.5. If we specify, what will happen? There is an error. Let us try to fix that. So how do we give that y then? Let us ask Sage itself.
It takes y max and y min.
Maybe I have to give it like that. Okay, thank you. So in that case, can I specify y min equal to? Are you suggesting something like this?
Yes, sir.
Okay.
Y min, not in the bracket, outside bracket.
Here itself. Then I need to specify x min here, right? Will it work otherwise? Maybe I will give here also. Otherwise, I don't know whether
No,
this.
it works.
Let us see, and after that we will remove. If this is not required, we will remove it. Y min, Y max. Okay. Yes, good. Thank you. So here y min and y max is working from minus 0.5 to 0.5. Here actually we are that cutting down the range, that the values of the sine function, even though it's plotted, it's not displaying. Okay. Now if you do not give this the keywords x max, what will happen? Okay, that's also working fine. But I think we cannot exclude this y min y max here, right? Let us even try to do that. This may not work. Anyway, try. No, that's not working. So the keywords y min and y max is definitely necessary there, but x min and x max we can ignore. But for the sake of understanding, probably it is better to just include x min and x max here, because otherwise we will be confused what exactly these things are. That is not actually a good practice to ignore x min and x max at one point and including y min and y max at another point. So we can control the y directions, y axis like this using this. Okay, sorry, I have not started sharing the Google Sheet. Those who are interested may use the Google Sheet for copying and pasting. Let me just start. Just 1 second. just starting a Google sheet, Google document. This is 11. Okay, the Google document link is here. Okay, so let me just copy and paste this entire thing. This is not required. Okay, let us see the remaining commands remaining options as well as available. Xmax, Xmin is there. Detect poles, we have already seen that. Legend level also, that option also we have seen. I wanted to just give you the colors. Fill color, we haven't used that option. Fill color, we haven't used. Okay, we will use that. But even before thickness, we have used hue. Okay, I wanted this to find out all the colors. Okay, one thing. So fill color. Let us try to see that fill color option. How do that work? Plot maybe x square. X square within the range -1 to 1, and fill color, I don't know, is it true or the color I have to specify. So fill color true, it's not actually working. So let us try to see once again what exactly the fill color stands for. What is that? Just one second. Fill color. Maybe we have to give the color itself. Not true. By default, probably the color is something else. Let us try to give, but where will we be filling that we have to see. No, it's not even fill. Fill is equal to true also, maybe we have to turn on. Let us even turn that on. Is it filling? Fill equal to true, fill color is equal to green. Why is it not showing? See, P equal to. Sorry, green small letter. Okay, it's filling below. It's filling below the curve, right? It's filling below the curve. Okay, let us try to see something else. P1, P2 equal to, what happens with the sign function? I'm just trying to see sign function within this, fill color, some other color, P1 plus P2. Okay, maybe I will suppress even this. Okay, it's yeah, from the curve to the x-axis it's filling. Okay, so from the curve to x-axis. from the curve to x-axis. That's the direction. Okay, that's it. Yeah, I wanted to tell that the colors available. I think this command should give the colors. These are the color codes available. I just sorted. Okay, if I simply ask for printing the colors, what will happen? Print colors. So what will happen is that it's coming as when I apply sorted, what happens is that it's sorted and only that color name is appearing. Okay, that sorted function will take only that that key. This is actually something known as a dictionary in SageMath. So corresponding to one color, there are different codings. You can see that automatic is this, and the color Alice blue corresponds to RGB color. This it's defined like this. So whenever we are using the name constant Alice color, automatically this RGB color is taken. So when we ask for printing sorted colors, only this only the corresponding keys are displayed. This is the key. Automatic is the key. Alice blue is the key, and aquamarine is another key, etc. Okay, these are the colors available to us. Any of these colored names, named constants, we can use for giving a specific color. Otherwise, we may have to use what do you call this, RGB coloring. Okay, the sorted colors. That's the command I used. Let me update the Google Sheet with this. Yes, updated. Yeah, there is one more thing that we have been seeing some axis around all these plots. Okay, if you do not want this axis, what you can do is, suppose that we do not want this axis, we can suppress the axis to be, we can give the axis option to be false. If you give axis to be false, what happens is, okay, this is not necessary. If you give the axis to be false, you can see that it's simply a plain graph without any axis. And we can give frames to be true. I don't know whether frames is capital F or small f. I think frame. Yeah, a frame will appear like this. Okay, these are two options. One is axis equal to false and frame equal to true. And we can even give both these options to be true. Should work. Both these are working, but the numbering is going towards the frame. By default, axis is true and frame is false. Updating Google Sheet once again, updated. Okay, so there is one more option to specify actually the color. We have seen already that using the RGB color we can programmatically change the color styles. Okay, there is one more way, one more command which is known as hue. Right. Okay, for example, suppose that okay, let us see how to do that actually. Let's try to, yesterday itself we have seen how to draw a circle. We have seen how to draw a circle, and let us now try to generate some nice picture using this hue command. Hue, this is what I am going to use for changing colors. So suppose that we want to get most of the colors. Okay, let us try to see that first. We will try to create polygons and fill with different colors. That's what we are trying to do now. So polygons starting with the x-axis and x coordinates are continuously changing, and with some constant width. Okay, we will do it in a for loop. For x in.
Sir, I have one question.
Yeah.
Yes.
Please.
Sir, in the fill color, if the color was filling the part with the x-axis, is it possible to fill the color from curve to y-axis?
The graph to y-axis. Right? Is that what you want?
Yes. So, like if you are trying to plot x square curve from -1 to 1, and I want to fill with respect to the y-axis, not the x-axis.
I don't exactly think so, because by the definition the fill color is actually doing like this. But if you want from x-axis to the curve to y-axis, so what essentially you are asking is, okay, I understand that question. I will try to answer that, but at present I don't exactly know how to do that. There is actually something known as a lambda function kind of thing. I will try to explain that thing that actually fills between any two curves also you can actually fill, but not using this fill color command. Okay, so see that this y-axis is nothing but it's a curve, right? Do you agree with that?
Exactly. So by using lambda command then.
Yeah, using the lambda command you can fill from the curve to y-axis, which is again considering y-axis as a curve, because between any two curves you can fill. Okay, towards the end of this session we will do that. Okay, please just remind me by some 7:45 or something like that. Please just remind me. We will go to that part. Okay, thank you. But not directly using this fill command, because this fill color by definition it fills between curve to x-axis. That's it. We cannot change. I don't think that we can change that behavior. That's not a default behavior. If you are changing it, that's not the default behavior. We are using some other trick. Okay. So, yeah, the next thing I wanted to create using we are trying to see how to fill color programmatically using the hue and this, what do you call, the circle thing. Okay, for not circle, we'll try to use rectangles. Rectangle is much better. For x in which range? Okay, let us see 0, 0.1. If the 0 point decimal thing is not accepted, we will try to do something else, etc. To 4. Okay, let us see if it's working first of all. If this 0.1 etc. is, yes, it's working definitely. So next is, let us try to plot a rectangle. So how do we plot a rectangle? So plotting rectangle, one easy way should be to just plot it as a polygon. That's one thing. Okay. Or otherwise we can actually create one function itself instead of okay, we will use the polygon itself. Let us use the polygon. So if you want to plot a rectangle using the polygon, what we have to do. So what are the coordinates that we have to understand first of all? The left coordinate of x is going to be just x itself. The right coordinate is going to be x plus 0.01 because we are using the range to be equal to 0.01. The width of the width between consecutive points to be equal to the difference between the consecutive points to be equal to 0.01. So the left coordinate is 0. The right coordinate is going to be equal to. So we will make squares. So if we make squares, or otherwise we will make a y height to be always equal to 1. Height equal to 1. So x in this. So we will make a rectangle. P is the graphics object. P is the graphics object. Let us now take P plus equal to, we are going to add a square to this by using a polygon. Polygon, we have to specify the list of points. So the list of points we have to specify. So from where to where, how did we do that? Polygon yesterday, was it, okay, let me just see. What was that yesterday? Polygon, it's a list of, yeah, list of points, list of lists. So first point is x, next point is x plus 0.1. But instead of that, why can't I change this to be equal to 0.1 so that we can change 0 plus 0.1. Sorry, 0 plus width, x plus width. So that is first point. No, sorry, first point is x, actually 0, sorry, x0. Next point is x plus width. What is the next point? X plus width, 0 again. And what is the y point? I want to construct a rectangle. Y point is going to be equal to, the height is where I would like this to be taken. What is next? Where do we want to go after that? I want to go up to the left of this height. So that's going to be once again equal to x and height. So instead of trying it in a loop, let us just try to see it as a single one. But in that case, I need to specify this x. Let us see what is this. Okay, we are getting it right. Maybe we can reduce this height to 0.5. Okay, now in the loop. Now in the loop. But here we want to change the color. We want to get some color. Okay, in which way we want to get the color? Let us take the color to be what was that? Fill color, I guess, right? Fill color equal to, suppose for the time being I use the RGB thing. After that I will try to use hue. RGB 1 by, or otherwise 1 by 1 plus x. I don't know whether I am doing it correctly or not. I am just trying. Or otherwise I will simply put x. RGB x plus 0.1, x plus 0.2. Let us try to see what exactly fill color. Whether or not to fill edge color. What is it? RGB color. but we are not getting distinct colors here. How to get a distinct color, because the first coordinate probably is always the same. Shall I use 1 by something randomly? I am trying. I do not have anything specific in my mind. To get some interesting picture, that's it. Should be RGB color. X, this is correct. This is also correct. One bracket is missing. But instead of even this, I can try with something called hue, equal to 1 by again I'm just using u to the power x, so that will be not 0. So what are the possible values of hue? This is a hue, it's a kind of hue saturation value, but this is from where to where it's going, I don't exactly know. Hue is from 0. Okay, let us try to see some help about hue. Yeah, it's here. Convert a hue saturation value to a valid color, in particular h is equal to 0. H is equal to 0, h is equal to 1. Hue, okay, but just by giving h, hue is accepting just one value also. Graphics. RGB color hue 5, hue equal to 5. H is a number, the color is hue. S is a number. We are just specifying one number, which is the hue. Okay, if you specify instead of just h alone, we can even specify, I think, 1 by e raised to x, x, what will happen if we specify like this? No, even that is not working. So, hue is just a number for the stage thing. Hue is just a number here. But how is it controlled and what is the range? That's what I'm wondering. So polygon, let us try to see. Polygon, what are the options available here? Okay, what we can try to see is, let us try to list all the colors. Hue is equal to, let us try to plot hue is equal to 0, what it will be if we just give 0 everywhere. Is equal to 0 is red, so 1 is again red, so 0.3 is, it's green, red, green. Okay, so it's again from 0 to 1. 0.6 is blue, 0.8 is not exactly. So I don't know. It's probably ranging from 0 to 1. Okay, well, let us try with the 1.1. What will happen? 1.1 is this, and what about 0.1? 0.1 also. Therefore, hue is also ranging between 0 and 1. It seems. Okay, that's what I understand from this. So as far as I know, the only thing I can definitely say is that with hue can be given as a number, and with that hue the colors are changing. That's it. So what is the previous thing we gave? 1 by e raised to x, because 1 by e raised to x, we know that 1 by e raised to x gives the values between 0 and 1, because e is a number more than 1, and we are taking e is 2 point something, and we are taking x to be in the range 0 to 4, so we will be getting something definitely between 0 and 1. That's why we were getting some nice colors there. Okay, that's it. I think there is the option called hue. That's the only thing I wanted to say. And we can, in fact, yeah, instead of adding like this, we can do one more thing. We can probably do one more thing. So what is that one more thing? So instead of using this command structure, we can just sum. So sum p equal to sum of all the polygons, sum of all these polygons as a list of all the polygons for x in this range. This also should work. P equal to let me just see, otherwise I will give instead of P, P1, P1. Okay, what is this? Plus for int and list. Where is the plus I am using? Am I using the plus anywhere? This is not required. Sorry, I'm just summing here. Where is that error message? Where exactly returns some expression? Where is that coming? P1 is equal to some polygon for x in, x is equal to x plus width. Oh, sorry, where is that? That x is, yeah, x is definitely there. What is the problem with that? P1 is equal to this, x plus this. So how I close this? Polygon x0, x plus width height, x width for x in, so this is closed. So what is the problem it's saying? Once again, P1, show P1. So it says that the error is here. But where is that error? Unsupported for int and list. Am I adding? Where is that int? Okay, let me just suppress these two. So I don't know whether it is because of this or not. Sum polygon that polygon is correct. x0, x plus width, x plus height, etc. For x in 0, 0 plus width, maybe this is not required as a list. Okay, let us just try to remove this. Probably this is not required. Sum of all polygons. Sorry, not here. That's it. Okay. So what's happening here is that we are summing all the polygons from summing in the sense that these are all plots, and some command is quite flexible in the sense that it can understand that whether we are actually summing a few numbers or few plots or whatever things that we are allowed to sum in SageMath can be summed using the sum command also. Okay, so if we can add two numbers, we can add it using sum. If we can add two plots, we can add it using sum. So all this is possible. Updating the worksheet. Okay, so after seeing all these options associated with plot, now we are moving towards something called implicit plot. We know that there are several. Sorry.
Excuse me, sir. Here slash is used. Why slash is used?
Okay, that is just for breaking the line, ma'am.
Oh, thank you.
So that if you are not breaking the line like this, I think there will be an error message. Okay, let us try to see that. It's not happening here, but so I think it's because of the 4. Okay. So otherwise, what the problem is that suppose that you are in the middle of a line which you are supposed to continue till the end of that particular line, middle of some expression. If you are willing to break the line so that you can see exactly what's happening, because otherwise it will completely go outside the border of the box we are typing inside. So for that you can use this backslash. For example, here it's not required, it seems. It's not creating an error. If it's there, if it's not there, it's not creating an error, but sometimes it happens. For example, suppose that I am typing x equal to 5 plus 6 and star 3. Okay, that actually gives me an error. But if I put this and print x, it's giving the answer.
Oh, thank you.
Okay, this is used for making understand Sage that you are not actually breaking the line, you are suppressing the line break basically. You are trying to break the line, but at the same time you do not want Sage to consider it as a line break. So this is a kind of escape character. Backslash is called an escape character usually, and that is used for suppressing the meaning of whatever symbol is following. Here, after the backslash symbol, I have pressed an enter key, which is a new line character. So if new line character comes into the picture, Sage understands that we are breaking the line and it expects another expression in the next line. So it assumes that previous line expression is complete. Here we are informing Sage that we have not completed. Please do not consider enter key as going to the next line. That's the meaning of it. Right. Now we are going towards something called implicit plot. As I told, there are several functions which are defined as implicit functions, like x square plus y square equal to 1, that circle. From that x square plus y square equal to 1, we recover the explicit function by using two functions basically. We split that function into 2. Y is equal to square root of 1 minus x square and y is equal to minus square root of 1 minus x square. To avoid that, there is a function called there is a plotting method in SageMath called implicit plot. Implicit plot is used when we have implicit functions to plot. Okay, implicit, just like plot. X square plus y square equal to 1. Here remember that x square plus y square equal to equal to 1. Now we have to specify x range as well as y range. X within the range, suppose minus 1, 1, y also in the same range.
We have to define variables x and y.
But variable y we have already defined previously, I guess. Previous definition, am I missing that? But what is happening? No, contour level is fine. X square plus y square equal to 1. X is within minus 1, 1. Okay, let me just again define. But I was understanding that x usually you don't have to define. X is always there available. But y previously I think we had defined. Let us try anyway. I think that previous definition is no longer there, or otherwise I was with the impression that here I have defined. Maybe I deleted that because of that problem. Okay, anyway. So this is with implicit plot is coming with a frame. Maybe we can extend this to, okay, not necessary. And almost all other options that are associated with plot can be applied even here, like the coloring options and all. I remember that even with implicit plot, it can actually happen that the aspect ratio that may go wrong sometimes. So now we can define any type of plots here. Now I have already defined this y, so I don't have to define y again. So y square equal to 4x, the parabola, y square equal to. So you need to be using double equal to. Only part of the parabola, so that otherwise you need to extend this y and x to say y square equal to 4x. So x is always positive, so y only you need to increment. So implicit plot also can be added, just like the usual plot. All the commands, all the options associated with plot will work even with this implicit plot. So there is one more thing, so that whenever we want to make some guess from the picture, sometimes we may require to see that graph page kind of lines. So that is known as grid lines. Okay, so we can see some grid lines. So while showing P equal to this plot, show P. I think you can use it like this only. Let us see the effect of this. There are two more options associated with these grid lines. One option is major. Let us see the difference between these two. Okay, what about minor? So grid lines are becoming much more smaller. Okay, if you give major, which is the default thing, it becomes larger grids are shown, larger squares are shown. If you are using smaller ones, you need to use the keyword minor. Yes.
What is the difference between plot and implicit plot?
Plot can be used when you have the function y is equal to f of x readily available. In the case of x square plus y square equal to 1, you don't have the function y readily available with you, right? You need to recover the function, but not in all the cases you can recover easily. For example, suppose that your function is x square plus y cube equal to, or something, some polynomial kind of function, suppose x square plus 2xy plus y square equal to 1. Suppose that that's your function. So how will you recover y from that? So in that case, you need to use implicit plot. If you can recover, you can directly use that. Otherwise, you need to use implicit plot. And one more thing, here I have already defined this this variable y. So again and again, I need not do that, because if you are defining the variable y, here variable x and y I have defined using a single command, x space y. But if I use x y, it will not be treated as, it will be treated as a single variable. We should not do that. Give one space or a comma. Here I have defined x and y as variables, but defining x as a variable is not necessary, because Sage always takes the name x to be a variable if you have not, even if you have not defined it explicitly. But every other variable names you need to clearly define, explicitly define. So y you need to define, x you need not define. But once you have defined y in one particular cell, whatever cell coming down, that y will be available to you. Okay, once you have defined it. Not only the cells coming below, but in the previous cells also, if you want, you can go and modify using y. because once y is defined, it's stored into the memory of Sage. It's available everywhere in that worksheet. So you don't have to again and again define. That's what I'm saying. Y once defined, you can use it anywhere. Okay, implicit plot. This is the function that I was saying about x square plus 2 star x star y plus y square equal to say 1 within x and y ranges, the same range. Maybe I should change the range to something else, x, y ranges to something else. It's a parallel line. Why? Maybe because it represents a parallel line. X square plus 2xy plus y square. What is it exactly? Is it x plus y into x? No, not x plus y into. How do we split that? X square plus 2xy plus y square. I don't know how exactly, but anyway.
And straight line.
They are straight lines, right? Represents a straight line.
X
Yeah.
plus y equals to 1, x plus y.
Yes, that's why we are getting it like that. Otherwise, we need to change it to something else. Then you will get a curve. I changed it to x square plus 2xy plus y cube. So you can define functions like this. You can plot, and you can club implicit plot and plot. There is no problem. Plot x square within minus 1, 1. You can club these two. This is very small. Maybe we can change it to 2. Plot and implicit plot can be clubbed. So any two types of plots can be clubbed. But remember that you are not supposed to club 3-dimensional plot with 2-dimensional plot. It may not work. I don't know whether it will work. It may work, but I suspect whether, because these two are different objects, it may not properly work. 3-dimensional plots we have not anyway seen. We have been only looking at the 2-dimensional plots so far. So implicit plot, I have updated the Google Sheet with that. There is the parametric plot also available for us. So what is the parametric plot? Parametric plot means that we are representing a function, x and y coordinates both are represented using a single parameter. For example, we know that the circle can be represented using the parameters sin t and cos t, right, where t is ranging between 0 to 2 pi. So that's how we use parametric plot. So it depends on our need, our use, that for what purpose we exactly want to define, for what purpose we exactly want to plot, and in which way the function is represented. So all these functions, essentially what happens is that all these functions are actually translated into the usual plot, and Sage is plotting using the usual plot itself, but we will not be knowing. We are issuing different commands like parametric plot, implicit plot, etc., circle, etc. But finally everything goes to the plot command, and Sage translates all these to corresponding plot commands. So parametric plot, so x and y we have to specify. So suppose we give cos t, sin t, where t in the range 0 to 2 pi. T is not defined. Once again, same problem. Exactly the same kind of plot we will be getting. Now, if you give uh, 2t and t square, we will be getting, we know that this is or t and 4t square, this is y is equal to, no, y square equal to 1, right? Y square equal to 4t. This is a parameter, right? For star t. Oh, half of the parabola. Minus 1. The parametric representation of the parabola is used here. See, everywhere here we can use this what you call grid lines. There is no problem. Grid lines. This command is allowed in every case. In fact, grid lines command we are not using along with plot, but we are instead of using it along with the show command. I don't know whether if you use the grid line command along with directly with the plot, will it work? I don't really know. Let us see. Grid line is not actually a command associated with this plot. Here also it will work. You can put it even here inside this. Now we have polar plotting also. Just like parametric plot, we have polar plotting. So just use the range of theta. Polar plot. So using the r theta structure. Okay, let us try to view the r theta polar plot structure here. Polar plot. What should we plot? Sine square within the x range. Let us see. Sine x square, where x within 0 to pi So can you guess what exactly might have happened here? Okay, let us see sin x to understand what exactly might have happened here. Just use sin x, or maybe even x. Let us see x. What is it? So here, corresponding to each x in the range 0 to 2 pi, what happens is that the corresponding value is found, and that is taken as a polar coordinate value. So here you have the point like r comma theta, right? Theta is coming from 0 to 2 pi, correspondingly the r is found, and at a distance of r distance, the theta angle is marked. So for example, suppose now that just give 1, suppose. What is this? Just a circle. Because in every angle this 1 is plotted. Okay. So corresponding to every angle this 1 is plotted. One distance is plotted. Corresponding to 0 angle, corresponding to pi by 2 angle, etc. Now here, x square or x itself. So what is one point? So 0, 0 is one point, right? 0, 0 is the original point. After that, 0 pi by 2 comes. What is 0 pi by 2? 0 pi by 2 is, sorry, not 0 pi by 2. When we get pi by 2, when x becomes pi by 2, the point becomes pi by 2 pi by 2. R is pi by 2 pi by 2. R theta is equal to pi by 2 pi by 2 means that in the angle pi by 2, in the angle pi by 2, go up to pi by 2 distance. Point, let us see. Point pi by 2, not in the angle pi by 2 direction, which is x equal to 0, pi by 2. Let's see. See this? So when we take x to be equal to pi by 2, what happens is, in the this is the angle. So angle is taken as pi by 2. So in the angle pi by 2, this is r. This is of the form r theta. Okay, r is compared to r is a function of theta. So if you use here sin theta, what happens is that you will be getting a function like this. So here you have theta here, but r is this distance. So r is this distance means that sine can go up to sine will be moving in the range -1 to 1. So that's why it's coming like this. So if you take x to the power 5, you will be getting a much more colorful thing. Just sin x, you will be getting something like this. Sin 2x, you will be getting this. 3x, 3 parallels. 4, 5, 'This is what polar plotting is. So r theta is constructed, that's it. And r theta is taken as not as an xy coordinate but as a polar coordinate, but in the polar coordinate. So the Google Sheet is updated. Please try. So many familiar pictures like the cardioid, etc. can be constructed easily using this polar plot. So cardioid, I think the equation of that, what is the equation of cardioid? Is it 2 plus 2 cos theta? You just see the equation of cardioid. R equal to 2 into 1 plus cos theta. Let's try to see 2 into 1 plus cos theta. What is that? 2 into 1 plus cos x. Oh, sorry, 2 into. Yeah, this is the cardioid. And you can again use this fill color option also here. If you want to fill, maybe fill equal to 2 is required. Okay, now as I told previously that filling between the curves. Now suppose that we have, suppose we define two curves. Suppose we plot. Suppose that we create two circles. So creating circles using implicit functions is much better, I think. So we can plot using what do you call, using the same plot command itself we can actually plot. Right, we don't have to plot, use multiple plot commands. Plot two circles we want. So two circles we want means implicit plot. Implicit plot, suppose that I want x square plus y square equal to 1, and suppose let us define it as a list. Whenever we want to plot multiple graphs, multiple functions, we have to keep it as a list. So now x square plus y square equal to 2. So 2 of them. Okay. So x range and y range, x between for both the functions, both these, maybe let's take it to be equal to 4, between -2 to 2, and y -2 to 2. So what is that? X is within this implicit plot, x square plus y square, x between these two ranges, Okay, let me just check the implicit plot. Sorry.
I think parametric plot, because you have used square bracket.
Here. Did I use the tuple? No, not even that. Implicit plot. Let me just see. Okay, this I am doing correctly only. What's the mistake? Okay, let me just try to use instead of implicit plot. Let me just try to see with plot and see if my commands are correct or not. Plot x square. Let's try with this. And x within the range -1 to 1. Okay, this is working. Here have I mixed these two things. Square bracket. I used previously square bracket only. Okay, what's the problem? Let us see. Come down and see. Tuple object is not covered. Just 1 second. Multiple. Or can I just give it as a comma separated thing? X square plus y square, implicit plot is not accepting more than one at a time. Why? Okay, maybe that this is not working, that combining functions is not working in the implicit plot. Only in the plot it's probably working. Okay, let me just check that later. So plot it's anyway working. So x square, x cube. Let me just take it to be this. This is anyway working. So if I fill where is it filling now? It is towards the x-axis, right? Both these curves towards the x-axis. X square is the parabola and x cube is the other one. Or otherwise I will simply take square root of x square and square root of 1 minus x square. Okay, now my intention is that I want from this 1 minus x square up to x square I want to fill, right? Okay, that's what I want. So for that I am going to use from 0 to 1 I have to fill that. From the first one to the second one. Okay, let me just give that option. Fill. The command structure is that from where to where I have to mention, but from where to where. Okay, let me just see. The first filling is from, I'll try to explain that after this. First filling 0 to 1. Okay, what happens after this? Fill equal to, I have already given. So fill equal to true. Instead of that, I am slightly modifying it. Fill from, okay, I should keep it as a dictionary, not as this. What is happening now exactly? Let's see. Oh, now the problem is that, so what is the first curve? So let us just try to add one more curve so that we can easily understand what exactly is happening. So maybe square root of 1 minus x square, I will add circles. That's better to understand. Square root of concentric circles, of course. So I need to reduce the radius, right, or increase the radius. 4. But in that case, I need to change this to minus 10 to some 10. Suppose I take a large range. Too many things. 4. What's happening? Square root of 4 minus, am I getting something negative here? Yes, probably, yes. 4 minus x square. So I should not take, that's a problem. Square root of, if I take it like this, 4 minus x square. So x square plus y square equal to 4, or y equal to square root of 4 minus x square. But I should not take, okay, I will do one thing. I will change all these. So this is not allowed. So how do I otherwise get? Maybe I can take a constant. I can take parabolas. I can lift it upwards. Y equal to x square. I will take x square. X square plus 1. Should I take it like this? X square plus 1. Square root is not required. Okay, this is better. X square plus 1. X square plus 2. There is no filling now. There is no filling now here. So 0 to 1 it's filling. So which is the curve x square? X square is the bottommost curve. From 0 to 1 it's filled. Okay, let us see. 1, 2. Will it fill? Now from 1 to 2 it's filled. Let's try once again. So suppose that we fill from 0 to 1 and 1 to 2, what will happen? Suppose that we fill from 0 to 1 and 1 to 2. Okay, 0 to 1 and 1 to 2. The same color is appearing, right? Suppose we need to change the color now. Let us change the color. So if you want to change the color, everywhere we need to specify the color, right? So otherwise, can we specify the fill color to be different things? Fill color, suppose that we give fill color also as a list, will it work? I don't know, I'm just trying. If I give two optional colors, will it work? Yes. Fill color we can give as, so green is filled from 0 to 1 and from 1 to 2 blue is filled. Suppose we take another x square plus 3 and suppose we give orange, now breaking the line, and now suppose 2 to 3, will it work? Yes. So if you want to give different colors, you need to specify it in the list. Now the filling is happening from the 0th curve to the first curve. So if you put 0 to 1, 2, what will happen? There also we can experiment. Let's try to remove this. Okay, maybe we will do it in a different picture. This we have anyway done correctly. So let us copy and paste it here. Suppose that I keep 1 to 2 instead of all these and remove these. Will it work? I don't know, I'm just experimenting. No, only 0 to 1 only have it. So if I give 0 to 2, then how many curves are there? 0, 1, 2, 3, 4. Yes, that's happening. So 2 curves have been filled. 0 to 1 it's smaller. Okay, so this is how we can fill between curves, right? But we need to carefully define the ranges, so that otherwise the problem is that from that curve to the next curve, what will happen is that the filling will spill over also. If you are using a larger curve compared to one curve, if the other curve is very large, we don't know whether it's going to be exactly the area in between or not. It is taken from that curve to the other curve. But somehow in the implicit plot this is not working. Maybe in polar plot this will work, and parametric plot also this will work. Okay, let me just copy and paste. This lambda function is not necessary here. It's a direct thing. There is no lambda function required here. I previously told that lambda function is probably required, but doesn't seem to be so. But within the implicit plot, right? I have updated the Google Sheet, Google Bookshop, Google document. Now I think previously the question was that how to fill from x to y. Now I think that's it's a clear thing, because if you consider y as the curve x equal to a constant. Yeah, but again one more question, that how to define x equal to a constant there. Okay, between x square and x equal to 0, sorry, this is y equal to 0, not x equal to 0.
X minus 2, we may take x minus 2.
X minus 2. X minus 2 is just, this is y is equal to x minus 2, no? You wanted x equal to 0 instead.
Yes.
But I am thinking how to achieve that x equal to 0. Implicit plot it's easy, but implicit plot is not accepting this multiple plotting somehow. In the parametric plot, if we even parametric plot, yeah.
Plus will work. Plus implicit plot.
But if you are using the plus, the problem is that the fill command may not work, because these two are different plots.
Oh, yes.
We want to use the fill, no. So why this implicit plot? That's what I am wondering about. Is x square plus y square equal to 1? Previously also we tried this, but anyway try once again. X minus 1, 1, and y also minus 1, 1. I hope that this is correct what I did, but still the mistake is there. It is not accepting things inside the list. Tuple object is not callable is what the error message is. So it is not okay. Maybe I can simply remove this and put a comma here, because I have already specified this x and y parameters using the variables x and y variable names equal to 2. Even that is not working. Implicit plot takes 3. Okay, let me just take it as a tuple once again. If it's a tuple, will it work? Even that's not working. So how do we represent y equal to x equal to 0? But x equal to 0, there is no control over y, right? Okay, let me just see.
X minus 2 is equal to 0.
That is implicit plot once again. I'm just trying x and y. Fill is axis. Okay, let me just see one more attempt. Graphics. So I don't really see XY step filling up to Y. Filling up to Y. The fill options are all working inside plot only, but not in. But the surprising thing
Your
is.
screen is not visible.
Sorry?
Your screen is not visible.
Oh, has it gone? Just 1 second, I will reshare.
Okay.
Screen. Now, is it coming now?
Yes, sir.
But did it go for a while? Did it go off for a while?
Last 2-3 minutes.
Okay. Okay, just 1 second. I'll just try 1 second. Okay, I will try to find out that thing. I don't exactly know that how to fill up to y-axis, because I was thinking that implicit plot should have actually saved. It should have actually done the trick, but somehow implicit plot is not accepting multiple plots inside the same command. That would have been the easiest way to solve this issue. Implicit plot, multiple plot. That's what we actually want, but somehow that's not working. Multiple implicit plot. It says that it can be a list.
Not exactly the y-axis, but we can write y is equal to 1 crore x. Means we increase gradient.
But that's only that's okay. What you are saying is that we can probably plot a line which is very close to y, right?
Yes.
Okay, that's actually a trick. A line with not much of what you call. That's of course that's possible, but that's not actually the correct answer. That should not be the way. That's what I'm wondering. That's quite possible. For example, if you are defining x to be, so you want x to be equal to 0, so x to be equal to 0.00 something if you define, definitely that's going to work. We want x to be equal to 0, but instead of that, we can define, so what we can suggest here then, instead of x square, x minus 2, x minus a huge value.
Increase gradient, gradient.
So we wanted x to be equal to 0, right? So x to be equal to 0, how can that actually be solved? So simply x is this. Oh, you want 2x, 3x like that.
Leave 1 lakh times x. Increase the gradient.
No, that becomes almost y equal to, this is x square. No, in that case, Sage will automatically adjust so that it will not actually give you that the desired output. Sage will adjust the graphical size of that window. That should not be the way. I think we will be able to find. I will try to tell that. I will try to find out and I will try to tell that thing, because if it's working in the implicit plot or if it's working in the parametric plot. So in the parametric plot, how will you define the y-axis? Let's try that way also. Let us see if in parametric plot we can achieve this. This is not possible. First of all, we need to see if we can plot 2 at a time or not. T square is a parabola, where since t is already defined, I think this should not create a problem for us. Let us see if we can plot 2 at a time first of all. Parametric plot, here it is. Okay. Let's try to see if parametric plot is going to work. Parametric plot, this is how we did. Now if we suppose that we enclose this in a list, will it work? No, even that's not working. Even parametric plot also it's not going to, not accepting. Only plot is accepting somehow. Only that plot function is accepting more than one function simultaneously. That is the only one giving. So some hack like what you suggested can actually be done. But let us see. I will try to find out if there are any other way to do that thing. Okay. That plotting up to y, is it possible using some other trick? I will try to see. I cannot say right now because one more thing is using polar plot. So polar plot seems to parametric plot, not parametric plot actually. This polar plot is also having a single function inside that. So polar plot maybe probably can be useful for us. But how will you represent the y-axis of the polar plot? Let us try to do that. Of course, that is also not the correct solution, but I am just trying to see if in something it's working. Polar plot is here. This is the polar plot. try to see the polar plot and trying to plot multiple functions here. Sine 5x and one is a circle, we know, so let us put both. One is the unit circle. Okay, here it's working, so this is fine. But how do we represent y-axis in polar plot? So now we need to know, suppose that we want to represent the parabola and y-axis simultaneously. How do we do that? What is the representation of parabola? The parabola is in the polar coordinates. So parabola we represent as, so what is the representation? We just check a polar equation of y square equal to 4x. How do we convert this into polar coordinate? That's the question. I'm not seeing that polar coordinates anywhere, but why is it like that? For ellipse and all these things we know. Okay, we will take the ellipse first. For ellipse it's, I think, a cos theta and b sin theta, right? So we need to fill from x-axis to, from that curve to y-axis. So let us just take circle first of all, circle itself. So in the case of circle, it's r equal to 1. Circle. Now what is y-axis? How do we get y-axis? Y-axis means that we always need to go up to pi by 2, right? So whatever is the angle, we need to go to pi by 2. R theta. But there also we will not get, the same kind of problem will again happen here, because we cannot, here the x is completely, x keeps on changing. Polar plot, we cannot change r and get theta. Here we want theta to be fixed. The same kind of problem once again. I think all these problems are commonly, all these problems are linked together. See here also, you cannot represent y-axis using polar coordinates, because if you want to represent y-axis using polar coordinates, what you want is corresponding to every x value, so which is theta, corresponding to every angle. If you keep a fixed value for y, you will be getting the circle. But on the other hand, what you actually want is corresponding to every radius you want a fixed angle. Okay, that's not happening here. So you will not get y-axis even here, even using this plot. So that essentially means that the problems are interlinked. Okay, so I'm not seeing at present any solution to that, but I'll try to find out that. I don't see any immediate solution to what I have asked for. So let me just think about it and try to locate one solution for that. Okay, now one more plotting I want to introduce before stopping, that is known as list plot. So given a list, we are trying to plot something. Given a list of points, we are trying to plot. So list plot. List plot. So list plot, as the name suggests, we need a list, and using that list we are going to plot. So what list we need? So this simply means that it's a set of points. So there is no continuous connection, that's the only thing. So if we have points like this, we will not connect. I or this plot, maybe we can simply take 1, 2, etc. 10. Suppose that we plot this. So it is just this. Only the set of points you are going to get. Now if you take more points, you will be definitely getting more dots. So 0.1. So that linking of these points is not happening. The connecting of these lines is not happening. That's it. 0, 0.1, etc. After 10, if you take, this will be a more or less a consecutive line. Okay, so we just update the Google document with this. You can actually approximate any number of some other function also using this list plot. For example, suppose that you want to approximate the graph of sine function. We know that sine function we are getting as a continuous curve, but instead of that, if you want a non-continuous curve, maybe we can use sine x for x in 0, 0.1, etc. 2 pi, but you need this as a list. You will get an approximate sine because we have taken sine points here. See, the good thing with list plot is that suppose that we have done some computation, suppose that we have done some experiment using which we have got some data. So if you do not know, most probably we do not know in that particular scenario that to corresponding to which type of function that the curve is going. So what you can do is you can try to plot, you can try to do some list plotting. Maybe from that list plotting you can try to understand that what type of function it corresponds to. If that curve is familiar to you, if it's a parabolic curve, if it's a circular curve, if it's a straight line type of thing, you can make a guess. But of course, the numerical methods like interpolation is definitely there, using which you can construct the polynomial itself, an approximate polynomial itself. That's of course there, but for an initial impression, probably you can use this list plot as a tool. This tool becomes somewhat handy when you have some discrete data. So what you essentially need is x coordinates and y coordinates are so x coordinates are already here. So corresponding to that, y coordinates are considered, and that's plotted. That's what's happening here. Let's plot sin x for x, and it essentially means that. So here, what's happening here then? 1, 2, etc. after 10. What's happening here and what's happening here? 0, 0.1, etc. So here x and y are taken to be from up to where it's going, up to let's plot 0, 0.1. See, corresponding to the 0 is plotted at 0 and 0.1 is plotted at 1, etc. There are 100 points. So x coordinates we have not specified. X coordinates are automatically taken to be 1, 2, 3, 4, etc. And what about here? Here also exactly the same thing. See, the sine curve is not plotted exactly in the same way, but instead of that, sine curve is plotted from 0 to 60. Because approximately 0 to 60, more than 60, because approximately those many points are there. It looks like the sine curve, but it is not actually the sine curve. Right? It's not the sine curve actually, it looks like. But instead of that, if you want the x and y coordinates to be related, probably what you can do is you need to mention that the specific points. For example, suppose that you want this plot something like this. If you make a dictionary of points, I'm just checking how do we find an alternate thing. Just 1 second, I'm just checking that how do we plot corresponding to the x coordinate we specify. Here what's happening is that the x coordinate we are not specifying, but instead of that the x coordinates are getting automatically plotted. X coordinates are automatically being found. Okay, but for that what you have to do is that you need to just keep it as a point corresponding to value, dictionary format you are supposed to provide in this format. Okay, I will show it in a small example first. Okay, suppose that list plot, instead of this, suppose that I am giving what should I do instead of this 0.1 x 1. Let's see if it's working. Okay, this is working. Now one more point. So here I am specifying x colon y, and in a dictionary, this is known as not actually a set. This notation, when we used with some this colons inside, that is known as a dictionary in SageMath as well as Python. So this is a dictionary format. 0.2 corresponding to 2. Is it coming properly? Where is 2? Yes, 0.2 corresponding to 2. So this is happening. Now if you want to map this sine curve in this way, what we have to do is we have to actually find out the dictionary like this. Sin x or x colon sin x, but in that way you are not going to get actually a list of points. Okay, let us see anyway. X sin x, what is the result of this? This may not actually work. Okay, let me just make all the points here. What I want is x sin x. Okay, I am just saying PTS. I am just making all these x sin x's. I am just saying PTS equal to list of all. What should I call that? List of all. I don't know exactly what to do here. I want x colon sin x. So we'll append work with the dictionary. That's what I'm wondering. Append to list is working, but to dictionary I am wondering whether it's going to work. But if I want to, so okay, I will do one thing. So PTS, I will just keep it as a dictionary. So how do I keep it as a dictionary? If I just do something like this, list plot x sin x. Okay, if I straight away try to implement this, will it work? x comma list plot x. No, that's not working. So what I essentially want is, just like this, I wanted the values to be here. 0.1 is this, 0.2 is this. Okay, I will try to do one trick. I don't know whether that will succeed. One final trick I am trying. So x, y codes. So the first value I will create. The first value, what will I do? Equal to the first one. Let me try this one. 0 sine 0. Okay, this is 1. Now let's try to see. So this is essentially a dictionary, and the type of this is nothing but, this is of class dictionary. That's fine. Now I am trying to append. Will append work? I don't know. If append is working, it's fine. If it's not working, we need to do something else. Append. What to append? An extra value. So what is the next value? 0.1. 0.1. Or otherwise I will just take this value and try to put it as this. Will it work? That seems to be working. Uh, 0.1 corresponds to, okay, that seems to be working. So if that is that's the thing, then what I can do is, let us try to, for x in this range, I'm trying to do something, xy x equal to sin x. But here 0 is already there, therefore 0.2 onwards is going to be fine. So what is the output? X in this range. So we are getting a few things here. Now list plot. List plot. Yes, this is within the range. That's correct. So we used a trick to create a list of xy coordinates. We used somewhat a trick. This is not a directly achieved thing, but there is a kind of trick. But there is of course an alternate way also. The alternate way is something known as sipping. Okay, something known as sipping. I will take that also, instead of doing all these things. So x coordinates is given to us. We know that. X coordinates, these are. Now y coordinates, what are they? Y coordinates are sine of, I don't know, sine of x coordinates. Will it work directly like that? Okay, let us try to see. Print y coordinates. Or otherwise we will loop sine x for x in. That's all. Now we are going to sip. List plot, list sip. That's the function I am using. X and y to see if it's working. X, comma y to see if it's working. the alternate way. So this is the first way, that's the alternate way. That's easier, much more easier. Let me update the Google document finally. Okay, the first one is updated. And the second one is also updated. Done. So I think the feedback link, has that been already posted? Yeah, it's already here. Yeah, and another thing that I wanted to just inform is, I think Rahul Nayak, he was asking about the non-working of SageMath in the Windows system. When I tried, I was able to get successful results. I would like to ask one thing, one output, because from the screenshot that he has sent to me, I am not very sure about what exactly the error message is. Can you please do one thing, that in the background you are seeing a black colored window. Is that correct?
Probably yes.
Yeah, because whenever we are starting the SageMath system, a black colored terminal type of window or command line prompt kind of window is opening up.
So I have actually used the software itself. I mean the icon itself.
No, that's what I'm saying. When you are double clicking on that icon,
Yeah.
a black colored window or blue colored window, I don't know what exactly.
Yeah, black color. Yeah.
Yeah, it pops up, and from that only after that automatically either Google Chrome or Microsoft Edge opens up, right?
Yes.
So in the background,
You
yeah.
mean to say CMD, right, sir?
Sorry.
You mean to say the CMD?
Yeah, CMD, exactly. CMD. That's in Linux. It's known as a terminal. So what my request is that when you are seeing the error, immediately after that you can go to that black colored window and copy the entire messages to the mail and please send it to me, because I could not reproduce that exact mirror in my machine.
Okay, fine.
So
I have tried the other way also, that is by using Jupyter. I opened Jupyter notebook and there I applied SageMath. It's not working, as well as when the SageMath was, the Jupyter notebook was open. I've changed this thing from Python to SageMath.
So basically what I understand is that this is the kind of some permission issue using which in the Windows machine SageMath is unable to access certain resources, maybe some libraries, but that what exactly is the problem we can find out only by checking that that background running that CMD window. So if we can copy the command from that, probably we can guess, because I could not reproduce the mistake. That's the problem.
Sure, sir.
So
Another thing, the C files which you have sent, I think it's in the format of Python EYNT, but those files opened on my Jupyter notebook. They are running. So I don't know why exactly the new file is not running.
no, that is not actually running. You are seeing that my file actually consists of the output as well.
Okay.
You are not running that, so you are seeing my own output. So
I'll send you the.
So after seeing that probably the background messages, we can probably make a guess. You also can have a look at that. And one more suggestion is that, so you will be standing inside one particular folder when you are opening that Jupyter window. Try to change it to some other folder instead of the C folder. If you have a D drive or something like that, you can simply go to the D drive and start creating a file there, because if it's a writing issue, that can be probably fixed using that.
Sure, sir, I'll try.
So there are two suggestions. One is that you move to another document folder before creating a new SageMath document. Second thing is, copy the background messages while you are seeing the error message. Immediately go back to that black colored CMD window, copy the error message and please post it to me.
Yeah, sure, sir.
Okay, thank you. And if there are any questions, there is one one thing that that is still left to be done. That is that filling from the curve to the y-axis is still not done. I will try to solve that, and I'll try to give you an answer tomorrow. I was thinking that using implicit plot that can be actually achieved, but implicit plot doesn't seem to permit plotting two functions simultaneously. We'll try to see if there is a hack or not. I'll try to explain that tomorrow. If there are any other questions, please ask me. Thank you.
Thank you very much, sir.
So if there are no questions, we will tomorrow we will be going towards some calculus, and we will be doing, I think that's what according to the schedule we are supposed to do. Tomorrow we have calculus related stuff we will be doing, and finding derivatives on all this stuff. After that we will be again coming back to the plotting, because we will be using this to understand basically some calculus related concepts can be easily understood using the plotting concepts as well. So thank you, and we will meet tomorrow again at the same time, 6 o'clock. Thank you.
Okay, thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.